When you choose colors for scientific purposes, let's discuss a couple of points. So the first question is always, which color should I use? And that depends really strongly on your data. If you have categorical data, you can vary the hue, but we discussed in a previous unit that the best case scenario is sometimes to still stay with grayscale. If you have quantitative data, if this data is in sequential values, then you use one hue and you vary the saturation. For example, you go from deep blue to light blue. Alternatively, if you have diverging quantitative values, you typically use two hues, going from a dark blue, for example, through white and to red. Do pay attention when you pick a diverging color scheme whether the central value is white or gray. Depending on your background color of a white or gray, it can look also as if there is simply missing data. So do pay attention to this. If you decide which color you want to be using for your color schemes, always remember to be colorblind friendly. Around 10% of the male population and less than 1% of the female population is in fact colorblind. So what does that mean? We see here a colored image above and a stacked bar chart, a really quite ugly one, below. With normal vision, we can in the above image see some red parts, some green parts and some yellow parts, which are appearing where green and red is overlapping. In the lower part we can see blue parts, orange parts and green parts in the stacked bars. To a person with the most common form of color blindness, the image and the stacked bar are illegible. The image actually appears as if it only has one color, so they would be completely lost if you now point the colorblind person to the red parts. Pay attention to the red parts of the image. They would not be able to know where to look. In this case of stacked bar scenario, it appears to them as if there are only two categories. So make sure that you are colorblind safe. And in the tools that I show in the last page, you will find also one tool that is quite nice. You can install it on your desktop and it can render the color display in the way that a colorblind person would see it. So it allows you to test your images and visualizations before publishing them. When you decide on which color, also consider the different visibilities of colors themselves. So each color has a different visibility, and this visibility depends on the lightness, the saturation, and also on the background color. For example, our eyes have receptors can differentiate blue and green and red, and yellow is So here is a visualization made by Brinton in 1939 of the different visibilities of a colored foreground and a colored or white background, and he sort of arranged it such that the first is the highest visibility, which is black lettering on a yellow background. Where do we see this very often? Everywhere where people want us to quickly see information. For example, taxis, for example, orientation, displays in airports, etc., etc. Very visible are also single hues on a white background, and nicely visible is also like either white on a very dark blue, for example, or black on white, obviously. As you go down the list, you have less and less visibility, and number 12, 13 and 14 are very hard for anyone to see, and especially 12 and 13 will be impossible to see anything for a colorblind person. The background is also really important when you vary the hue in, for example, charts. If you have the same hues on a white or on a dark background, some colors are no longer differentiable. So do pay attention to the background color when making a choice about which colors you want to be using in your visualization. The background colors also strongly influence our color perception. I already mentioned this, and here is a visualization of this. So the readability in principle based on font and text size, etc., is quite similar for both of the lines, but one of them we focus first on simply because it has a high contrast to the background. Don't ever do this at home, kids. So if you choose a background, make sure it's one that works on all desktops and that works on all screens and that works on all printed formats. If you need to choose, if you need to assign labels on a background, make sure, as I said before, that the text has needs very good contrast to be visible. When the background is dark, use a light gray, and when the background is light, use a dark gray. Sometimes you have to place text in visualizations on a patterned background. For example, if you label maps, if you label very vivid images, etc. If you have such cases, neither white nor black usually will work. What you can then do is to place the text nearby or next to the image, or you can place the text on a slightly higher contrast background box that sort of sets off the text from the rest of the image. If you use color, make sure that you do not misuse it in visualizations. So one thing that has to be remembered is that qualitative color schemes, which for example are rainbow color schemes or jet color schemes, they should not be used for quantitative data and vice versa. So here we see a rainbow color scheme, and sometimes it is used for encoding quantities along a common scale. The problem is that not every single person by heart remembers which sequence the rainbow has. Is it the above or the below? In contrast, if we have the sequence varied in which we vary just one hue, it is impossible to get the sequence orientation wrong. So every one of you can see that the above sequence is ordered by the quantity, while the sequence below is sort of jumbled around. So this is definitely higher than this, and it's not ordered by the value. So people tend to be very easy, people have great capacities to tell the sequence of colored items if the hue is varied, but they have great difficulties of finding out the sequence of rainbow colored items on a map, for example. It is also important to remember that divergent color schemes should never be used for sequential data, because this basically creates an artificial breakpoint into your data that is not there and should not be there and might be highly misleading. So here, for example, I sampled the price for one bowl of ice cream or one scoop of ice cream around Dresden. And it ranges from 72 cents to €1, €1.20, €1.50, and even €3, which is a delicious ice cream made by Pau Pau. What you can see here is that if you use for such sequential data a divergent color scheme, you sort of place a second meaning onto that information. For example, it looks like everything above €1.20 is what Helena considers way too expensive and color coded in red, while 70 cents and €1 is okay price. It could also mean that something completely different, which is that the red is really ice cream that I love and the blue is ice cream that I hate. But if you do not want to have such a second meaning by a diverging color scheme, usually what you should use in this case is one color that you vary by saturation only. If you use colors in, for example, a line chart or a bar chart that are extremely similar, make sure that people can still differentiate them. So in this case, we see a line chart from a long time ago when the 5 people were running to become the next president of the United States. And in this case, this is typical data that should be qualitatively, because they have nothing to do with each other. Donald Trump is not on the same scale as Marco Rubio. And in this case, what the authors should have picked was colors that have nothing to do with each other, instead of colors that look highly similar and along a scale. And from a distance, if you sort of are not really close to the screen, it's probably very hard to, in the line chart, tell apart who is Ben Carson and who's Ted Cruz. So do make sure that the colors are not too similar if you want people to be able to differentiate them. Sequential colors are should never be used for categorical data. I already said this before, and I'm sorry, there's a little typo in here. Our eyes can easily distinguish around 7 colors at a given time. If you have more than 7 categories, you have to consider creating some kind of groups in your data. And here are just 2 examples. We've seen these before. This is a pie chart with 80 or so categories. And good luck in finding out where this turquoise is compared to this turquoise. I cannot tell them apart at all. I would probably have to use a color meter and really go very close in order to find this or this in this pie chart. Similar scenario on the right hand side here. We also have a lot of different colors that are in addition placed on top of each other, so that we cannot tell them apart from each other anymore. So whenever you have too many items in one bar that you need colors for, consider some kind of grouping or faceting. Faceting basically means taking the information apart, making a pie chart with bigger groups and then a second pie chart with other subgroups of the data. For example, this was done in this case. Here we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items along the bar chart. A bar chart with 12 bars usually looks quite messy and looks like it has too much data usually. However, by grouping the data points into 3 larger categories, you sort of visually create 3 sections in this plot, and now each of these sections has less than 7 items, and you can get away with less colors. So this bar is about the career prospect of postdocs and what they do afterwards. So you sometimes have to think a little bit of how you could group your data into meaningful units, and then you can change the color scheme accordingly, such that not every single item has a different color. So background colors can also be very easily mislead your audiences. Basically, we already saw before that our eyes can trick us when a background color is used. And that's really dangerous when it's used for quantifying values from a colored scheme. So here you have two visualizations that illustrate this point. These four squares in here have the exact same color value of gray. However, while this one looks really dark because it's placed on a light background, this one looks really light in comparison because it's encompassed by a dark background. So if you now tell an audience that this is high and this is low, they would not believe you. If you tell them this is the same, they would probably also not believe you. So you have to sort of take into account that the background colors matter for the perceived quantity that your audience can see in this data. This is particularly true for colored heat maps or colored tables, you could also call them. In this case, make sure that your audience is always gonna have difficulties to find differently dark spots around here, but it will always find the one light spot very easily. That is, for example, this guy. So three last slides about color. One, if you choose color, make sure they fall into a color scheme. So be sure that you use a consistent color scheme throughout the entirety of your work. It really helps to orient the audience quickly if not every single figure in your paper has a new color scheme. And in the first one, your control group is red, in the second one your control group is suddenly blue, and in the last you remember to not use color and you show them in gray. So here's an example from my own paper where I tried that. So across the entire work I made sure that there are two categories and that the red is always used for a specific localization for RNAs and the blue is always used for the other localization of RNAs. By that I allowed my audience to basically read my entire manuscript and never have to reconsider what red and blue means. When you end up printing information, and sometimes that's still done, for example when you go to conference and you print posters, you have to make sure that the color codes are suitable for a printing machine. So basically the computers use an RGB color scheme while the printing machines recalculate this to a CMYK color scheme. So sometimes this can lead to your colors looking muted or somehow different than what they looked like on the computer. So if you want to make sure that something comes out of the printing machine exactly how you want it to look in RGB, you have to do a test print and basically adjust the colors to a CMYK color scale beforehand and double check if that still looks the way you want it, and good. So here are the promised resources for color. So Color Brewer was initially designed for maps, and it allows you to decide what kind of data you have. So basically it asks you, do you have sequential data, diverging data, or categorical data? And depending on which one it is and how many categories you have in the given data set, it makes a couple of suggestions for you to pick from that are scientifically and solid and distinguishable. They also have a button for choosing colorblind friendly versions, and do not be surprised, there basically is almost no colorblind possibilities to combine more than 3 colors. There is also things like Color Scheme Designer. These color scheme designers, they allow you to pick harmonious colors. So if you, for example, want to make a poster and you have all your data in red and you want to pick 2 more colors that sort of are nicely contrasting to that, then things like color scheme designers will help you. Color Oracle is the desktop installation that I would suggest you to try, because basically you can click on it and it renders your entire screen as if you are a colorblind person, and you can even pick different kind of color blindnesses to make sure that your visualizations are accessible to all audiences. And then you can also have a bit of fun with colors. For example, in this tool that allows you to pick a color scheme based on an uploaded photo. One last thing about color: whenever you want to try using a color, make sure it also works in grayscale, because you never know if people will have the possibility to see it in color, and the grayscale allows you to quickly assess if the contrast is really high enough and sufficiently for all audiences. So remember that the visibility of colors varies, that the color scheme must fit to the data that you have, and that you should be consistent across the entire work that you're publishing.